Molecularity of a reaction. Let us understand molecularity of a reaction. The number of reacting species, that is, atoms, ions, or molecules, taking part in an elementary reaction which must collide simultaneously in order to bring about a chemical reaction is called molecularity of a reaction. Note that elementary reaction is a single step reaction. Now, we will study the types of molecular reactions. The first type is unimolecular reactions. The reaction can be unimolecular when one reacting species is involved. Let us take an example. Let us decompose ammonium nitrite by heating it. On strongly heating, we get nitrogen and water. We find that the number of reacting species is 1, that is ammonium nitrite. Hence, it is unimolecular reaction. The next type is bimolecular reaction. Let us take a reaction. 2Hi gives H2 plus I2. Here, two species molecules form S2 and I2. As in above reaction step, two molecules are involved, that is, two molecules of Hi. Hence, it is a bimolecular reaction. The next type is trimolecular reactions. Let us take a reaction. 2NO plus O2 gives 2NO2. Here, three species react to form NO2. That is, two molecules of NO react with O2 to give one molecule of NO2. As in above reaction, number of reacting species are 3. That is, two molecules of NO and one molecule of O2. Hence, it is a trimolecular reaction. Complex reaction involving more than 3 molecules in the stoichiometric equation must take place in more than one step. It doesn't mean that reactions involving 1, 2, or 3 reactants are all elementary reactions. Let us take a reaction. KClO3 plus 6FeSO4 plus 3H2SO4 gives KCl plus 3Fe2SO4 whole thrice plus 3H2O. This reaction, which apparently seems to be of 10th order, is actually a second order reaction. This shows that this reaction takes place in several steps. The overall rate of the reaction is controlled by the slowest step in a reaction, called the rate determining step. Consider the decomposition of hydrogen peroxide, which is catalyzed by iodide ion in an alkaline medium. 2H2O2 gives 2H2O plus O2. This reaction is first order with respect to both H2O2 and I-. The rate equation for this reaction is found to be rate equals to minus d H2O2 by dt equals to K times concentration of H2O2 multiplied by concentration of I-. To know more about this reaction, refer to Know More button. Evidences suggest that this reaction takes place in two steps. The first step is S2O2 plus I minus gives S2O plus IO minus. The second step is S2O2 plus IO minus gives S2O plus I minus plus O2. Both the steps are bimolecular elementary reactions. Species IO- is called as an intermediate since it is formed during the course of the reaction, but not in the overall balanced equation.